So we know that the product rule, is the derivative, hold on here, one moment here. The derivative of a product of two functions, okay, the derivative of f times g, as you know, is f times g prime plus g times f prime. Okay, that's, how many remember the product rule from Calculus 1? Okay, excellent, excellent. Well, we can take advantage of the product rule. Excellent, excellent. We can use that to help us get a formula, a new integral formula. So what we can do here is we can integrate both sides. Thank you, Eva. We can integrate both sides of this equation. So I can integrate the left side and I can integrate the right side. Okay, and if you integrate the derivative here on the left, integration, let's see, zoom in a little bit. How's that? Now you ought to be able to zoom too. Hold on. Candace, you should have also an ability to zoom in on your, at least from what I understand. Okay, great, great. But now here, and I'm seeing a big hand. I don't know. I have a hand. Is my hand, I'm not sure how to make a big hand. I'm seeing a big hand float around here. I mean, do I? Oh, okay. Okay, we'll work with that. Thank you. So, okay. Oh, thank you, Candace. Thank you. All right, so if we integrate this derivative here, the integral of a derivative gives us just the function back. So the derivative of f times g, if we integrate that derivative, we just get f times g back. And then we're integrating the right side here, and that's what we have over here. So they're just trying to save a step, but they switch the sides of the equation. And now you have the integral of f times g prime plus g times f prime equals fx gx. Well, the integral of a sum, as you know, is the sum of the integrals. So now you have the integral of f times g prime, okay, the integral of f times g prime plus the integral of g times f prime equals f times g. We can rearrange the equation as this equation right here. The integral of f times g prime dx equals f of x times g of x minus the integral of g of x times f prime of x dx. This is what's called integration by parts. This formula is called integration by parts. And the formula in this form here, the formula is a little bit difficult to remember. So what mathematicians do is they want to make a formula that's easier to remember. And so they say, well, let's let u equal f of x. Let's let v equal g of x. I mean, we can do that. We're basically changing the variables. Well, we're not changing the variables, but we're making these substitutions so that it makes the formula, it breaks the formula down in an easier form. So if u equals f of x, you know, if u equals f of x, for instance, then du dx equals f prime of x. But that means that if u equals f of x, then du dx, that just means, hey, I'm taking the derivative of u with respect to x. So that's the same as f prime of x. But then du then would equal f prime of x dx. Similarly, if v equals g of x, dv would be g prime of x dx. And so by the substitution rule, the formula for integration by parts becomes this formula. Okay. The u is here. Sorry, that's u there. The g prime of x dx is dv. So u dv equals u v minus integral of v du. Okay, does that make, are we comfortable with that? Good, thank you, Tina. Thank you, Rodrigo. All right, so thank you, Candy. So now we have this great formula. Cologne likes it, we all love it, right? The integral of u dv equals uv minus the integral of v du. All right? You're going to be dreaming that formula. It almost sounds musical, doesn't it? What we're going to do now is now that we have this new integration by parts formula, let's see where it can be used. Okay, are there any questions? May I move forward to an example? All right, and as you know, this is in your ebook, what I just showed you. All right, thank you, everyone. We'll move forward. Whoops, hold on. So here's a problem, integration by parts, where we want the integral of t times the sine of t. I'm wondering how I make that hand. I had a big hand, but now my hand's a little hand. I wonder how I can make that hand bigger. Somebody's showing me something there. Maybe click on the pencil and then click on this. I mean, I can still see the little hand, but I'm trying to, maybe because you zoomed. Let me see. Well, I'm pretty zoomed in here. Cameron, I'm pretty well zoomed in here, but we'll figure it out. We'll figure it out. I will, hey, Labor Day weekend, right? I can figure that out. I mean, we're doing okay, but I'm going to figure that out. Let's see, zoom in, maybe. Maybe you're right, Cameron. I'll investigate it. Maybe you have a point. So okay, now, yeah, let's take our the other two. The only hand here should be mine. So let's go ahead and remove those other hands, if you would. Thank you, students. So could we use a substitution on this? Could we use a substitution? are the no, we could and well, Sergio, the product rule, the integration by parts is based on the product rule. We have the product of two functions, and we had that with substitution problems as well. But are the functions t and sine of t, or t, I should say t and sine of 7t, are they related at all to each other? I mean, are they in any way related? Because with substitution, the two functions, there's usually a relationship between them, like the one function's the derivative of the other, that sort of thing. But t and the sine of 7t, there's no real connection between those. So we're going to use integration by parts. Let's get to the solution here. So what we have to do is, again, here's the integration by parts formula. The integral of u dv equals uv minus integral of v du. So I'm starting out with this integral, and I have to identify, I guess what I want to say is I'm starting out on the left side here, integral of u dv. This is my I. This is my I integral. So I have to identify what u is going to be, and I have to identify what dv is going to be. I'm going to choose to let u equal t. I'm going to choose dv to be equal to the sine of 7t dt. Okay. Now, how did I know to do that? How did I know to let u be t and dv be sine of 7t dt? A lot of experience, and you're going to get that experience too. But for now, just take it on faith that that's what we want to do. Now that we've identified that, we have to then work out the right part of the integration by parts formula. The integral of u dv is equal to uv minus the integral of v du. Okay, so I know what u is, but I have to get the rest. So let me let you copy this down, okay, and I'll be right back, and we'll talk about this. I'll be right back. Okay, so, all right. So we let u equal t, and so then du would equal, well, if u equals t, du dt equals 1. So du is dt. Okay, so we know what du is. We know what so this formula here, this integration by parts formula, I need to, I need to get what's on the right side. So du, we know what that is. Now, dv was sine of 7t dt. Since that's the case, then v will be negative cosine of 7t over 7. But I know what you're thinking. Hey, where'd that come from? Where'd that come from? It's an antiderivative. It's an antiderivative. So dv dt, let's think about it like this. Okay. Could we go the other way? Could we go the other way? What if we said, hey, I think v's negative cosine of 7t over 7. If we differentiate dv, if we differentiate v with respect to t, we'll get the derivative of negative cosine of 7t over 7, right? And by the chain rule, that'll be negative 1/7 times, hold on here, now 1 moment. Yeah, so what I'm doing is I'm factoring out the negative 1/7 here. I'm factoring that out. Okay, and then the derivative of cosine of 7t is negative sine of 7t. And then the derivative of 7t is 7. So we get 7 sine, we get sine of 7t. Therefore, dv does equal sine of 7t dt. So what I'm trying to do there is say to you, I mean, we know, I went backwards. What I'm trying to do is I'm trying to justify, and I'm trying to justify to you why v is equal to negative cosine of 7t over 7. It's the antiderivative of sine of 7t. Okay, and if you differentiate v with respect to t, you do get sine of 7t dt. You get you get then dv is sine of 7t dt. So that's the right v being equal to negative cosine of 7t over 7 is correct, because dv is equal then to 7 sine of t dt, and that's what we started with. So to get the v from the dv, you have to take the antiderivative of whatever's in front of the dt. So Arian, the denominator for v, where that came from is, I'm good at taking derivatives in my head, and you're going to get good too. I mean, you watch, after a week, this is like going to be no problem for you. What's the antiderivative of sine of 7t? It's negative cosine of 7t over 7. I mean, normally what you would do is you would like make a substitution, right? And figure out what the antiderivative is. But you're going to get so good that that's going to be easy enough to do in your head. Okay, Arian, are you good with that? All right, great. So now we know what v is. We know what du is. We know what u and v are there. So now we can apply the integration by parts formula. And that's what I did here. The integral equals u times v minus the integral of v du. Du is dt, right? Are there any questions up to this step here? Please let me know if there are any questions.
I have a question.
Yes, not now, yes.
Professor?
Yes.
So I'm still a bit confused, because like when we said n, there's no more t, if that makes sense. We did the U. We multiplied the U. Sorry.
I'm having a little trouble. I mean, I can hear you now, but your voice is kind of breaking in and out.
Okay, so my question was, when we did that then, we only included the U and the V's, and I was just wondering, like, what happened to the D? I understand, like,
Oh, you understand now. You understand.
I understand how. No, I understand how you got the DV, but I just can't figure out why we didn't use the D instead. Like after we did that then.
You mean like this part here?
Like over here.
Oh, yeah. Point to me. That's a good idea. Point to me with your hand where you're a little uncomfortable.
So over here, like for the equation, it's U times dV, and then I was just curious why we didn't.
Well,
like I was a bit confused why we didn't use.
Well, yeah, the integration by parts formula here. The integration by parts formula. Let me use maybe green. This integration by parts formula here says the integral of u dv equals uv minus the integral of v du. Okay, that's the integration by parts formula. And what I did was, you see, I start on the left. The integral of u dv. So I identify u to be t and dv to be sine of 7t dt. That means then that I have, you know, the integral of u dv. And then I got to figure out what du is, because I need to know du, and I got to figure out what v is. And that's what we did. And now we just apply the formula. We apply that formula. So now our new integral is written as negative t times the cosine of 7t plus 1/7 times the integral of cosine of 7t dt. That's what. So we took this integral that we didn't have any chance that we could get. We couldn't get the antiderivative of that integral, but through using integration by parts, we were able to write the integral in this way. And the only thing left to integrate is right here, the integral of cosine of 7t. That's the only thing left. And the antiderivative of the cosine of 7t is sine of 7t over 7. Just to take the derivative of sine of 7t over 7. What's the derivative? Let me ask you, what's the derivative of the sine of 7t? What's the derivative of the sine of 7t?
It's negative cosine 7t divided by 7.
It's the derivative of sine of 7t.
Oh, sorry.
That's all right.
Sorry,
and people can chat the answer too.
It's negative cosine 7t. I'm pretty sure.
Well, the derivative of a sine is a cosine. So the derivative of the sine of 7t would be cosine of 7t, but remember the chain rule. You got to multiply by 7 because of the 7t. Derivative of 7t is 7. So you see the 7's cancel out, and you get cosine of 7t. And so this is your answer.
Okay.
All right. I know it's you know, it's like you're in a different world now, right? From Calculus 1, you're in like a, you know, it's like those Jurassic Park movies. You're in a different, the different world or whatever. They started off on the island and then they go somewhere else, and you know. Hopefully, though, no dinosaurs, right? To you know. Yeah. For the last part, Sir Fidel, I used the chain rule to. I did it like I got the antiderivative of the cosine of 7t, but to confirm that the derivative of the sine of 7t over 7 equals cosine of 7t. That's my way of checking that my antiderivatives right. To do that, I'm doing the chain rule in my mind. Okay. All right. All right. Are there any other good questions before we go to the next example? All right, Tina. Thank you, Tina. Thank you, Esther. All right, everybody has the example copy down good, or well, I should say. All right, well, let's move to the next example. Let's move to the next one. Oh, I'm sorry, one more thing. So then, of course, the integral of t times the sine of 7t dt is equal then to negative 1/7 t times the cosine of 7t plus 1/49 times the sine of 7t plus c. It's an indefinite integral, so we need our constant of integration in there. So you see, you found an antiderivative that you wouldn't know how to find. Okay, you wouldn't know how to find it. Okay. All right, one moment. Oh, hey, I'm still teaching. You doing all right? Yeah, hold on. Okay. One moment. Sure. Okay, let's go to the next example. I'll give you a moment to copy that down. Okay, so we have the integral of the arctangent of 4t dt. Now, you're used to taking the derivative of the arctangent, right? You're not used to integrating an arctangent. And it's clear that no substitution is going to be helpful here. No substitution is going to be, well, you could let u equal 4t and break the problem down a little bit. But if I want to do one where, I mean, we could do a little substitution to simplify the problem and then do an integration by parts. But let's just focus on integration by parts. Okay, so again, we need to figure out, you know, what is u going to be? And what's dv going to be? And what happens is when you do enough of these problems and get enough of them right, you develop a sense an intuitive feel for what you're going to let U equal and what you're going to let dV equal. If you pick a U and a dV and it wasn't the right choice, then you're not going to be able to solve the problem. You're going to see that pretty quickly. That means you have to go back and try to change your assignment of U and dV. But what we're going to do here is we're going to let U equal the arctangent of 4t. And we're going to let dV equal dt. Okay, let's try it. Let's try it. Okay. We'll let U equal the arctangent of 4t and dV equal dt. Okay, let's go to the solution here. So, okay, so once again, I have my integration by parts formula. The integral of U dV equals UV minus the integral of V du. And notice I'm setting the integral equal to I. Okay. U is the arctangent of 4t, and dt is equal to dV. So if I'm going to apply the formula, I need to work out the right side. And that means, well, I know what U and dV are, but I need to find out what du is, and I need to find out what V is in order to complete the formula. So if U is the arctangent of 4t, then du dt, by the chain rule, I mean the derivative of the arctangent of t, or the derivative of an arctangent of theta, I want to say this right, the derivative of the arctangent of x, okay, is 1 over 1 plus x squared. Well, we have the derivative of the arctangent of 4t. So that's going to be 1 over 1 plus 4t squared. But then by the chain rule, you have to take the derivative of the 4t, and that gets you a 4. So du then will equal 4 over 1 plus 16d squared dt. On the other hand, dv equals dt, that means v would have to equal t. Okay, and if you don't believe it, just say, okay, what's dv dt? Well, if v equals t, then dv dt right, if v equals t, then that's a v there, then dv dt would be dt dt. But that just equals 1, right? So if dv dt equals 1, then dv would equal dt. Hello, Neville. Good to see you. Glad you're here.
It's going way too fast.
Welcome to the class. Welcome to the class. So dv is equal to dt. Okay, so I'm just doing this to confirm. I want you to feel good that if dv equals dt, then v equals t. Okay. So now we apply the integration by parts formula for this section 5.6 problem. And we get this. Let me give you a moment to copy that down. And are there any questions? Cameron says, welcome to Jurassic Calculus. I like that.
I thought these the same thing as T. Wait, what was I doing? Oh, okay. V and T. Yeah.
Okay, so now what we'll do, if there are no questions, then let's move a little bit on here then. Well, so I'll bring this 4 here out in front of the integral. So now my integral I is going to equal t times the arctangent of 4t minus 4 times the integral of t over 1 plus 16t squared dt. All that's left to do is to find the antiderivative of t over 1 plus 16t squared. That's all that's left to do. So you've learned 2 approaches here. You've learned substitution and integration by parts. 2 integration techniques. If I want to get the integral of t over 1 plus, if I want to get the antiderivative of t over 1 plus 16t squared, which should we use? Integration by parts on that, or should we use substitution? Okay, Rodrigo thinks substitution. And he's right. He is right. So the question is, what would the substitution be? Okay. And I'll just mention this. Nabil, Nabil, I'm glad you're here. Since you joined us a little late, you might not be able to, like this example, you're not going to have the full work on it, but there will be a recording of today's lecture. Just, stay with us here, and you'll, all right, so that's right. Good, Rodrigo. Good, Tina. Let W equal 1 plus 16t squared. So I'm going to let W equal 1 plus 16t squared. Notice I'm not using U. I'm using a different. It's just like, hold on. For this integral here. I'm going to let W equal 1 plus 16t squared. And you notice I'm using a different variable for my substitution. I'm not using U because I already used my U and V variables in the integration by parts. So let's go to the next page. So, okay, W equals 1 plus 16t squared. Then dw dt is 32 dt. And then you can show that t dt is 1/32 dw. I work these problems we work out step by step, showing our work. This is what I'm going to want to see on your exam in order to get credit for your problems. Okay, I want to see work written out completely. And, I do give partial credit, but, to get naturally, work should be written out correctly and you don't want to lose points on a problem because you didn't show work. You want to always show your steps. So now we're down to this integral here. Are there any questions on that? All right. Well, now it's basically a piece of cake, as they say. So our integral is equal to t times the arctangent of 4t minus 1/8 times the integral of 1 over w dw. Do you remember what the integral is? The antiderivative is of 1 over w? Almost right, Tina. Almost right, Rodrigo. You're almost right with the log of w. There we go. Now, that's right, Michael and Rodrigo. The log of the absolute value of w. That's right, Calon. That's right. So, let me move to the next page. We're good here? May I move to the next page? Okay. One more minute. All right. Tina says, can you explain why we need the absolute sign? It's just the way the antiderivative of 1 over w is the absolute value of the antiderivative of 1 over w is the log of the absolute value of w plus a constant. And the absolute value, if you look back in your calculus 1, let's see, where did that log come in? You would have learned it in calculus 1. Let me see here, one moment. Okay, all right, Tina, all right. I was wondering what section that came in. Section 3.7. Section 3.7. If you look at section 3.7, example 6, they give some context to why the absolute value is needed. All right, are we good? Maybe move to the next page. Cameron's good, wonderful. Aaron, you're good? All right. Great. Actually, there's a little more here, isn't there? There's a little more. I forgot to, yeah, the integral is now equal to t times the arctangent of 4t minus 1/8 times the log of the absolute value of w plus a constant. Now, will WebAssign take this answer? Tina's right. Justice, Adriana, Kalam are all right. We did the antiderivative, but the original integral was with respect to t. So we have to take the w and substitute back in the 1 plus 16t squared. And that's what we do. But the absolute value of 1 plus 16t squared, 1 plus 16t squared is always positive. So we can drop the absolute values because we don't need them, and we get our final answer for the antiderivative.
Signed.
Rodrigo says, would we lose points if we've, if you had the absolute value of 1 plus 16t squared there, that would be okay, Rodrigo. That would be, it's an acceptable answer. And how do we know, Adriana says, to drop the absolute value? For any value of t, 1 plus 16t squared is going to be positive. So you can drop the absolute value. It's like saying, hey, the absolute value of 3, is equal to 3. You don't need the absolute value there. Yeah, the answer will be positive, right? Excellent, excellent. Now I want us to do one more problem before I set you off on your classwork. I'm thinking because the 5.6 section, that homework that's due next Tuesday, is this next example. I think you're going to need that to help you. All right, so let's go ahead then and move to the next example. Okay. We want the antiderivative of e to the negative theta times the cosine of 2 theta d theta. Now this is an interesting problem. You have a sinusoidal function multiplied by an exponentially decaying function. Okay, so it's what's called a dampening. You get what's called dampening, and you'll see that in your physics classes. But let you copy it down. Okay, so here we are again. Notice that we have the product of an exponential function, the product of this exponential function here, and this trig function here. The product of those two functions are not related to each other. Okay, so like the derivative of one function is not equal to the other function. So there's no way substitution is going to work here. I'm going to have to use integration by parts. So again, the question is, what are we going to let u equal to, and what are we going to let dv equal to? Well, in this problem, it isn't going to matter. This is one where, like, you could let u equal e to the negative theta, or v. You could let v equal e to the negative theta. It's not going to matter on this one. But I'm going to choose to let, I'm going to choose to let u equal cosine of 2 theta and dv equal to e to the negative theta d theta. So let me get to the solution here. This is an interesting one. Remember, you can write this integral as the integral, hold on. You can write this integral as the integral of cosine of 2 theta, okay, times e to the negative theta d theta. Okay, so we're going to let cosine of 2 theta be the u, and dv would equal e to the negative theta d theta. And we know that the integral of u dv is equal to u times v, trying to make this as good as I can, u times v minus the integral of v du, integration by parts. So this time I'm leaving out a few details. I mean, if u equals cosine of 2 theta, du is going to be negative 2 sine of theta d theta. Okay, and if dv is e to the negative theta d theta, then v will be e to the negative theta, and v will be negative e to the negative theta. Okay, why is the v value negative? Well, all right, if I put in the detail, dv d theta, Aaron's asking that, dv d theta, right, it's by the chain rule. It's going to be, hold on. No. Right, okay, that's dv d theta is the derivative of negative e to the negative theta. And as Tina points out, by the chain rule then, we'll factor the negative out, and then the derivative of e to the negative theta is e to the negative theta times negative 1. So dv d theta will equal, that's a negative 1 there, will equal e to the negative theta. Hence, then dv is equal to e to the negative theta d theta. Arian, does that clarify for you? Good. So, okay, we do an integration by parts. Here we go. We do integration by parts. Okay, so I got u times v minus the integral of, well, this whole thing here equals v times du. And then we can write that integral like that. Okay. Well, I can write the v. The v doesn't. I can do that, Surfiel. I mean, I could have written this as cosine of, like, Surfiel's asking about why do v times u. It just looked a little nicer to me. I know that v times u is u times v. It's the same thing. Okay, very good question. Okay, are there any other good questions? Okay, well, did this work? Did this work? Let's look at the integral that resulted. By letting u equal cosine of 2 theta and dv equal to e to the negative theta d theta, you know, I break down the integral and I'm left with finding this integral here. Does that integral look better than the original integral? Does it look worse, or does it look about the same? Tina thinks about the same. And I agree. I agree. It looks about the same. But it isn't worse. Okay, I'm not getting into a more complicated integral. So it gives okay. No, class not dismissed. Hold on. Hold on. Yeah, I had a power outage there. So, all right. Hold on here. I'll be back. All right. Hello, everyone. I'm back. So had a power outage there at my house. So sorry about that, but I'm back. Let's continue here. All right. So just clean this up. So what happened was, first of all, can everybody hear me okay? Maybe give me a thumbs up. Okay, good. And what did it show? Like, I mean, it didn't, like, was I like basically absent for 3 minutes and then I've logged back in and you see me? Is that basically what happened? Okay, all right. So, all right, very good. It said reconnecting. All right. Great. Well, so what happened was, so if this kind of thing happens, you know, I just reconnect and we continue the class. You know, it's remote technology, but we're doing fine. So I did integration by parts once, and I ended up with this integral. But the integral that the antiderivative I have to find is still no more difficult than what I started with. So you know what I'm going to do? I'm going to do integration by parts again. I'm going to do integration by parts again. I'm going to let u equal the sine of 2 theta and dv equal to e to the negative theta d theta. Okay, and so here we are. And look what happened. When I did the integration by parts again, I mean, I started with this. This is my original integral. I did integration by parts again, and I got the original integral back. Yeah, are you all, I mean, I know us having trouble seeing the annotation. Annotation, you mean like the pen, me circling things? That's interesting. Let me see, hang on. I don't know why that would be. Yeah, well, some of the annotation got wiped out. I think, wiped. I had to log back in, so, I mean, well, I don't know, but if you're seeing 3 blue circles, then that's good. Okay? But the point is, we have, what I mean, I could write now the integral. By integrating by parts twice, my integral I is equal to negative e to the negative theta times the cosine of 2 theta plus 2 times e to the negative theta times the sine of 2 theta minus 4 times my original integral. Okay, so let's make sure we're okay with this step here. And it's being recorded, so all right, hang on a minute. All right, all right, hold on. Let me try this. Hold on. Okay, just hold tight. I'm uploading this again, the file again. Okay, so I'm uploading the file again. I hope by uploading the file, this will take care of this issue some of you are telling me about. Thank you for your patience. Kahindi, yeah, during classwork, I can talk to you about the access code. Everybody has free access for 2 weeks in WebAssign. And then when the temporary access expires, WebAssign will prompt you to purchase access. I don't know why this is not coming up here. Should get up by now. Good. Good. Okay. Does everybody see, this is the page we were working on. This was in the notes. All right. Thank you, Tina. Thank you, Noah. So where we left off, thank you, everybody. Thank you, Adriana, Michael. Where we left off was we had this integral. Thank you, Colom. We had this integral to do. And what we're going to do, and remember, this is going to be in the recording. I'm going to make we're recording this, so if you, for some reason, you know, I mean, basically, we're just sort of starting back to where we left off before some of us, you know, got knocked out of the internet due to the power. So I'm going to use integration by parts again. And when I use integration by parts again, you know, here's the integration by parts again. We have negative e to the negative theta times the cosine of 2 theta minus 2 times that integral. So then when I do integration by parts on this integral here, I'm going to get that my integral equals negative e to the negative theta times cosine of 2 theta minus 2 times the integration by parts. And so the integral I then becomes this on the right. Okay. And notice what happened is we got our original integral I back. We got our original I back here. But we're not going to integrate a third time because we would just end up getting the integral of e to the negative. It's going to be an endless loop. That's right, Tina. It's going to be an endless loop. However, I have an integral I on the left and a minus 4 times integral I on the right. So what can we do to both sides? If we want to, can we get the integral I on one side? Yes, absolutely. How can we do that, Hindi and Tina? How can we get the integral I on one side? That's right. Add 4i to both sides. Very good. So I'd like to show that on the next page. Are we good here? Are we good? Is anybody still copying the notes? Or are we good?
Second, I'm still copying.
Okay. All right, Tyree. So this is a new experience for me, having a power outage at the house during the lecture, and for some of you too. But, you know, basically we log back in, and it looks like the recording stayed on. So that's good. Probably we just had we'll have some blankness for, you know, like some, I don't know, not blankness, but quietness or whatever for a few minutes.
Professor?
Yes, not now.
So for problems like this, do we pretty much repeat the process until we get?
Well, here's what we're going to do. Here's what we're going to do. Let me show you. So this is what we have. We have the integral equals negative e to the negative theta cosine 2 theta plus 2 times e to the negative theta sine 2 theta minus 4i. I'm going to add 4i. I'm going to add 4i to both sides of this equation, as Tina and Kahindi suggested. And by doing that, it's an equation. If I add 4i to the right side, I can add 4i to the left side. You know, the 4i's are going to cancel, and then I have 5i on the left side, and I can divide by 5 and solve for I. This is why you want to let your integral equal I. That's why it's a good thing to do. And we actually solved the problem. We solved the integral. How many think that's absolutely cool? What we just did here. Cameron likes it. Cameron, is it Jurassic Park quality? This integral, this problem? Indeed. Thank you. I mean, this is one of the most beautiful problems I've ever seen in math. Certainly, how many think this is kind of beautiful, what we did to solve this problem? Okay, great. Thank you, Snega. Thank you, Tina. Tina has a little scary face there, but she's okay. All right, so are there any questions? All right, well, what I'd like you to do, I'd like you to go into WebAssign, and let's spend the next 15 minutes of class working a little bit on section 5.6, the integration by parts problems. I want to just see if you can solve a couple of those problems from section 5.6. Even though they're not due till next Tuesday, I know 5.5 is due this Sunday, but that I'm confident you'll be able to do reasonably well. But let's see if 5.6, since that's probably a little harder for you, go into WebAssign, stay in the class session and go into WebAssign and see if you can get a couple of these 5.6 problems right. And watch out, there is one that has multiple choice. There is one there, or two that are multiple choice. So you got to be careful. You have limited tries on multiple choices. Okay, are there any questions? All right, I'll stop the recording. Oh, this is an equals here. This is an equals. Okay, Surfiel. Yeah, no, the 5.5 homework, I am going to make it show. It's just right now I deactivated all the assignments because I want everybody working on section 5.6 in this last 15 minutes. Okay. The reason I like that is because then, sometimes you'll have questions. Like the last class, I think somebody had, maybe it's, I don't know, it was one of my classes, somebody had questions on a problem, and another person was able to help in the chat window because they were working on the same kind of problem. And so that's why I like classwork, everybody to work on the same thing. But don't worry, we will activate those other assignments. All right. All right, does anybody else need, does everybody have the example copied down okay? All right, I'll